All right, folks. Welcome to our Shipping Safer Containers in 2026 webinar. I'm Patrick Smith. So without any further ado, let me introduce Erika Heidi, who's going to be talking about safer containers in 2026 and some of the dangers that we're seeing out there.
Hello, everybody. Thanks for joining us today. I'm Erika, and I am happy to be here today. We have the last learning labs of the year, so we are in a festive mood, getting ready for the holidays. So a little bit about me. I work at Chainguard since 2022. I helped with the container products. I built some of the images, some packages, so I'm involved since the beginning. I have a background in Linux containers and PHP. I developed PHP for a long time. So I work as DevRel engineer at Chainguard, and today I wanted to bring some information around container security, software supply chain security for developers. So culturally, it says that developers don't care about security, and we need to change that because we will see in a moment. But it's dangerous out there, folks. So it's important that we understand why we need to care as developers, and also understand some of the trending threat models that we are at risk as developers, and how to mitigate risks. Also, I'm going to share some concrete actions that you can do right now, this sprint, to start getting ready for 2026 with the right foot. And also, I'm going to show a little demo how to migrate using a tool that we have called DFC, how to migrate Docker files to use Chainguard containers. We will also see some comparisons, vulnerability comparisons of Chainguard containers and other popular container images. And yeah, around that, I will talk a little bit about also Chainguard libraries and other things that you can use to improve your application software supply chain security for 2026. So let's get started. There's a lot to cover. So why devs need to care? Supply chain attacks are on the rise, and they now target package managers and ecosystems directly. It's not only about the OS anymore, the operating system. They are targeting developer environments, basically. So developers own Docker files. It's usually us who introduce new dependencies. We choose the base images we're going to use in our Docker files. So we are the ones who can fix it from the source, from the beginning, to start from a base, from a secure foundation. There are some really important recent incidents that I will be talking about in a moment. So these are just three of like the most impactful incidents lately involving software supply chain security. We have the Utils incident from last year, and then we have the actions changed files action this year, and the childhoods that you probably heard about. I will talk a little bit about these incidents, what happened. And of course, I needed to add a mandatory XKCD comic. This is it reflects, illustrates so well how we build our applications today. We depend on a lot of stuff that we don't really know how it is deployed, what kind of measures the maintainers have on their computers, on their machines, where they are publishing packages. So it's really complicated. So first one that I wanted to talk about is the Utils incident. So this was a malicious tar release that was introduced by a long-term maintainer. So this was the most like impressive thing. It looked like a planned attack because the maintainer was 2+ years in the project, and they introduced this malicious payload. Like it was an obfuscated content that was introduced in the test suite, like a malformed payloads to be able to test. And it was a bit shady, a bit weird. And luckily for us, we have been really lucky. This was detected. I mean, contributors, other contributors of the project, people from the community have looked at the PRs and found it a bit weird that this was a very specific payloads. If you wanted to test like malformed payload, you can just get a one that is working and just change a few characters, all right? And that would be enough. But this was more weird. And some people, I saw the original pull request threads, and the comments were like, some comments questioning, like, why did you do that? And this was a 2-year maintainer that was a long-term in the project. So people might not question a lot because it's someone that is already a maintainer. But we are lucky that some folks who contribute to the project noticed that was something weird happening. And the person who discovered actually after installing, updating packages, this is an issue on OpenSSH service, and he noticed that was something weird when he logged in. There was taking a little more time, like a longer time to log in. There was something that was happening during the authentication process, and it was later researchers have found out that this was to allow unauthorized access. So it could be a backdoor or maybe a direct remote command execution exploit. So this the most difficult part is that this was not visible in the repository, in the source code. It was a shady payload in the test, so it was really hard to detect. It could have been catastrophic if we did not detect this early. Imagine this rolling out to Linux distributions and several containers, everything. It would be really a mess. So these are some of the headlines. I also added some of screenshots of headlines of all of these incidents. So the Utils backdoor, the supply chain RCA that got caught, because always highlighting that this one was caught, but we don't know for sure what is lurking around, let's say. This is also a spy novel embedded in a compression library, because it sounds a bit like a spy movie plot. The person infiltrates the open source project that is used largely and then introduces a malware, and then they can access remote systems through these. It could be targeted or not, we don't know. But yeah, it's kind of a spy thing. And also from CISA. So this was also a wake-up call to more maintainability, sustainability for open source ecosystem. There are issues, of course. We know that maintainers don't always have the resources to keep working on a project, and then having contributors is very important, but we don't have the resources to vet all contributors, so it's also hard for the maintainer. Also, this is from actually this year, 2025. It was on the Hacker News that researchers found the backdoor in dozens of Docker Hub images, and this is strange. Apparently, they claim it was for testing or for like research reasons that these images were published, but it's there, and we don't know for sure why. Okay, so let's talk now about a more recent one from this year. TJ Actions changed files. This was a GitHub Actions compromise. So this is a very popular GitHub action. changed files used by more than 20,000 repositories. And what they did was they injected a payload that dumped the CI/CD runner's memory. So it would expose sensitive environments, variables, and secrets directly into the workflow logs that you can see on the repository, on the actions tab, you can see. So this is public, and several repos were compromised and have the secrets exposed. So what happened was they were able to get access with a compromised personal access token from one maintainer, and this maintainer used this pet to maintain the project, right? So it had a lot of permissions, and so they were able to do a whole process to roll out this compromised version of the GitHub action. They merged the malicious commits, then new tags were released, and then retroactively updated existing tags. So even if you were using a tag, it would still be affected because they were able to update the tags to point to the same poisoned commit. So this is very serious too. And so some of the headlines, there were several industry leaders researching these, of course, these incidents. And there's, according to this research from Palo Alto, the target was Coinbase. There was a targeting Coinbase, and it expanded to reach that GitHub action. It also came from another action, Review Dog or something like that. Forgot the name now, but yeah. So it's very common lateral movement in these types of attacks. We see that a lot, get access to one project and then move to another project. Also from CISA, Review Dog. And the Hacker News also shared these. Over 23,000 repositories were affected, and it was really impactful, let's say. And then, of course, this is the most trendy right now that maybe you heard about. So right now, it has been probably mostly mitigated, but this was the peak was like November, and this is the second coming. So we had first Chai Hulud, the first one that was in October, and I think it was around October that it's hit the news, and it's the Chai Hulud, the first coming, targeted post-install script. So it was a post-install script. It would be triggered by a hook after installation of dependencies on NPM. And this one is a pre-install hook. So it runs before anything gets installed. So the objective was to harvest credentials. The first one was also had this goal of harvesting credentials, but only on the env, the local env. But this second one was much worse because it started harvesting credentials also in CI/CD and like clouds provided credentials, and it would exfiltrate data to GitHub repos that were controlled by the attacker. So at that time, if you search Chai Hulud on GitHub, then you see hundreds of repos that had credentials leaked. And I have a screenshot that I'll show in a moment. So this was really big. It would auto-infect any other packages maintained by the victim. So that's why it propagated so quickly. It was a devastating effect, very quick. 500 packages. The thing is that they Trojanized packages from big players in the industry for big packages like Zapier, Postman, Posthawk, they are used for by like thousands of people probably. So this is why it propagated also so fast. And the other thing that was very peculiar of this malware is that it's a worm. This is called a worm also because it can spread so easily and fast. And the thing is that they also had like a dead man switch thing where they were capable of destroying user data. So what happened was if the script would detect there was no communication with the controller on the infected host, they would perform commands. They would be able to make the controller delete the home directory on the host, maybe in a way to hide the attack or obfuscate or something, but also, of course, causing harm if they delete your home directory. Imagine this is very bad. So some of the headlines, these are more recent. And it's actually not, the researchers don't know for sure if it's from the same actors, like who created the first Chainguard and the second Kami. We don't know if they are the same group. So it's hard to say. And yeah, 25,000 repos and credential theft, basically. So this is the a screenshot from when it was going on. So if you search it for Chainguard migration, you get like hundreds of repos like that. Sometimes they have like a Chainguard migration on the description, different descriptions, and basically this is where they would exfiltrate the credentials too. Okay, so first, I wanted to give you this a little refresher on some recent incidents that we've seen in our industry. Just three, just to give you a taste of what it looks like. And let's talk about the trending threat models based on these attacks that are more recent, and what are the threat models, and how we can defend, how we can stay safe. So I would talk a little bit about each of these, but from the three incidents that I talked about, each incident has a different target, right? So the first one was OS packages. The target of the XZ malware was OS packages. So it wanted to infect packages that you install on your base OS, on the container or on your host. So the packages were compromised at build time, so it was hard to spot. So there was a payload, but the payload would download something else, would check for, it would download another script, and then it would run sometimes, not at all systems, but at some distros, it would execute and run the shady thing to open SSH, to open a backdoor. And so the threat models we see for OS packages are basically something at build time is much harder to spot, because on the source code, there's a lot of eyes looking, and at build time, no. But I'll talk a lot about that soon. And also another risk is hijacked repos. Not the open source, the code repo, but the repo where you pull directly the packages from, because you are not building from source. You are pulling the packages directly to your machine and using it. It's already built for your system. So it could be, something could be introduced there if they get access to the package repos where you download directly packages from. So the other incident we saw was at CI/CD, GitHub Actions. And one common vector is the PAT, the personal access token, that is stolen, acquired somehow And also tag hijacking, which happened with the changed files action, because then you use an action and you point it to a tag thinking that this is safer than using latest. But the tags can also be hijacked and points to an infected commit. And the third incident we saw, the shy huluds, the target of this was the local dev environments. So the way they do for reaching that is by compromised libraries, like user lanes dependencies, things that you install on your app, npm packages, composer packages from PHP or any other like that. And also obscure auto-executable scripts, because we have a lot of that with npm, with our frameworks. They all have some kind of thing to facilitate and like pre-install, post-install hooks and things like that. This is also a little bit dangerous and a way for them to get access. The main goals of these actors are always to secret exposure, like to expose your credentials, your tokens, your APIs, your private keys, and to gain unauthorized access. And then from one point, they can laterally move, and they will try to move to get more access, and then that's how it goes. So you may think, but I'm a developer. I'm not a security person. I don't do DevOps. I don't do platform engineering or whatever. But yes, you are the targets. Understand that. You are here. You can be a target for tag hijacking, because we often set up our GitHub actions, and then we use actions that are already available, of course, like changed files, the checkout actions, very popular. There are many GitHub actions that we all use. And basically, if a tag is hijacked and you point into that tag, then you will be affected. And local dev environments, this is the place to be, because a malicious actor wants access, secret exposure. This is all there in our environments, in our development environments. There's a lot of env variables there with secrets, right? Some API tokens and things like that, your keys. So this is the target. This is where they want to be. Be aware. So I'm going to talk a little bit more in details about the three trending threat models that we see in the incidents and how you can protect yourself. So the OS packages, basically they target runtime environments with a poisoned package distribution channel. Maybe I use Debian. Let's say you use Debian, and the package repo is compromised, and you download packages that are compromised, or the case with the XUtil, an attacker infiltrates a project and introduces obfuscated malicious code that is triggered only at build time. So there are less eyes to see. It bypasses source code scans and CI/CD verifications, because is all happening in the repo, in the source codes. And at build time, everything can happen. Everything can happen at build time, and you are not there looking. So depending on what you use, what systems you use, is a GitHub action. It can be exploited. Maybe they get access through GitHub action, and then they will introduce something at build time to the package. There's lots of things they can do. How to stay safe. So this is very hard. As a maintainer, you need to trust at some point. So you need to have a minimal vetting process for contributors to give them access, especially if you want to give them right access to the repo. This is very important. Don't treat it like a trivial thing. And like you can enforce Git signing it's a good practice. So you can ensure that the person who is committing is actually the person who looks like it is. In the case of Utils, that would not help because the person was already trusted. He was 2 years in the project. A malware check could maybe have helped with that to detect the malformed the payloads, malicious payloads. And there is a project called malcontent. You can search for it, and then this is something that you could potentially use. Could be helpful. And for as a developer, what can you do? Use trusted sources, and safe-based images is like the most important thing. Where are your packages coming from, right? How large is your surface for attack? Because the more packages you have, the more vectors, the more is the bigger is the threat. You have more windows or doors to let them in. Now let's have a look at the trending threat models for GitHub Actions based on what we saw at the changed files. So what is the threat model? The attacker gets access to a personal access token from a maintainer, and then they publish a new version of the action. Whoever is pointing to latest is already screwed. Let's say if you are pointing to latest, you already get it, the version that is infected. And if you are pointing to a tag, you can still be a victim, because they can also override. It's possible to override tags to change the commits that a tag points to. And that's what they did with the changed files action. So how to stay safe? As a maintainer, avoid PATs, always avoid PATs. So there is a project Chainguard created called OctoSTS that provides short-lived tokens that you can use in these workflows, in GitHub Actions workflows, to mitigate the risk of using personal access tokens, because those are typically long-lived tokens, and you forget they are there even, and they have sometimes they give a lot of access, write access, and to change things on a repo. So this is bad. And you can also use rule sets to stop tags being updated. So this would prevent it would limit a lot the reach of the changed files incidents, because then only people pointing to latest would get the wrong version. And as a developer, use digest instead of tags. You should not point to tags for GitHub Actions or for also container images, because tags can change. You should point to a mutable identifier that is digest. Digest exists for that. So you can point to that specific build, and you will not get an update. Of course, this is not going to be updated. You need to update the digests. I'll talk a little bit about that later. And the third incident that we analyzed, and the threat model for the local dev environments, is that the attacker injects malicious code in one. It's just enough to get like one or two popular library infected to have that code that's pre-install hook there. And the code is triggered in automated execution, such as a pre-install hook, could be also post-install, like the first shy hulud, and at the developer's host. So it can download additional payloads. Usually the initial malicious payload that they includes in the codes is very obfuscated, small. So for the shy hulud, for instance, it would run the bun environments to download the payloads, the actual malicious payloads. So it would be looking at the npm file, you would not notice anything. It looked normal, but then the payload that it would download, that's the one who would do the things and steal all your things, credentials, secrets. For the maintainer, all previous precautions. Vet your contributors, limits write access to the repo, create safeguards for your tags, and don't use personal access tokens, use short-lived tokens and things like that. And for the developer, containerize everything. So imagine if you get infected by Chainguard and then they have access to all your projects, everything that is on your host machine, and they can even delete files and make changes to your host, to your system. So it's very dangerous. This is the time to start containerizing your dev environments too. Don't wait until it's too late. Imagine this scenario. If you are infected by Chainguard and you were on a container environment, then it is more likely that it would stay contained, unless there was something else that they could exploit to get out of the container. But that is much harder. So if you are running your dev on a containerized environment, you would only leak the environment variables and the secrets that were pertaining that environments, the containerized one, which is usually just dev credentials and things like that. So it's much less dangerous. But if it goes wild in your host machine, then we don't know what could happen. So yeah, we know actually. They could even delete files, so it's very dangerous. And also, it doesn't make so much a difference if you use a very insecure container image, because then they can escape the container. If you use a run image as root, use some base image from 2022 full of vulnerabilities, then they can escape the container also. So you have to use a safe base and also safe package sources that could mitigate the risk of build time tampering and the post and pre-install scripts that are dangerous also. So depending on where you pull your packages from, you have these can be mitigated. And I'll talk about this soon. Okay, let's talk about mitigating risks then. Well, I gave you an overview of the recent incidents and the threat models they used, and what can be trending for the coming year, since those, especially Chainguard, was so successful in what it tried to attempt, that we can see more attacks like that coming in the future. So we have to be aware of that. And now is it kind of a recap of what I talked about as strategies, but more concrete steps, more concrete actions. So containers are the new runtime. Everything is containers now. So you put everything there. There's a base, there is your application with all the dependencies and things. Everything is there. And still, containers are not safe by default. There are pain points with generic images, popular container images that you pull from Docker Hub. Bloated images, full of CVEs, vulnerabilities, random official images, has official on the name, but is an image based on Ubuntu 22.04. Insecure defaults, like running as root and things like that. Developers will literally run any base image. And that's true. In the past, especially, you would it was assumed that containers were safe, so you would run anything without thinking twice. But we need to change this. Even for the development environment, is not good enough to run anything. And with Chainguard containers, you get minimal base images that are low to zero CVEs, free of vulnerabilities. They are secure by default because they have strategies. They already have in place some strategies. For instance, they run as a non-root user by default. They are locked down. The distroless version has no shell, no package manager, so it's really just a runtime, makes it much more secure for workloads. And when you make the change, you see smaller images, fewer vulnerables, like 0 most of the time, sometimes 1, 2, but we will see some comparisons soon. And I will also show the demo, so you will see with your own eyes. Handling dependency chaos. A random package. This is how it happens nowadays, like a random npm package, and like, do you trust me? And yes, devs will trust. If it does what they want, they will add as a dependency without thinking twice. We need to do better, right? And so if you imagine that is the whole software supply chain security as an iceberg where your app sits at the top, there is a big portion that there are libraries, and there is also the OS at the bottom, the host, the VM, the container. There's a lot of stuff on the bottom, but there is a large portion of it. There is libraries, and the thing is that we control these. Like, we are the ones who introduce these dependencies in our code. It's different from like a system dependency, when sometimes you need a package to make things work. Like, you really need a package, curl, Git, or like a library on your Linux to be able to run, I don't know, FFmpeg on your application, things like that. Well, there are vulnerabilities there, but also on the application level, on the ecosystem level, we introduce so many dependencies that we don't know. It is much easier to create a new npm package or a composer package from PHP ecosystem, and just create a shady GitHub repo and put my thing there and release this. There is also typo squaring attacks that, if you never heard about it, is when a bad actor will create a package with a name that is very similar to a popular package, and then it will introduce malware there. And then if one person writes a tutorial and uses that by mistake or purposely, then it's enough for other people to start adding that as a dependency. And with AI nowadays, we also don't know what can happen if AI starts suggesting, hallucinating package names that don't exist. This is already actually happened. I don't know how it is nowadays. It's still bad, but I heard about this situation happened before. So common typos that people do when requesting packages end up being created as a fake library, and then AI suggests that, and then it's a cycle, whole cycle. Anyways, so public registries, they are uncurated, unpredictable, and hard to audit. That's like what I was saying. Like, anyone can create a package and just put it there. And with Chainguard libraries, you will eliminate threats, totally eliminate at build and distribution. If a threat is at the source code, like we build everything from source, the same way we do for containers, for our packages, is the same factory where we build Chainguard OS and our container images. So we provide provenance information, SBOMs, signatures, everything to prove the provenance of the package. And it's also built on a safe environment, a very secure environment. So we don't run the post-install scripts, so we can detect any weird network connections happening during the build process, and we can prevent these to reach our users' machines. So it's the UX is the same. You're gonna use instead of just pointing to a public repo, you're going to be pointing to our repo for a safer default source for dependencies. You can also use, which what we advise, actually using a package proxy like JFrog Artifactory, and then you can proxy your packages from there. And the UX is the same, so devs will not feel the change much. It will not impact your day-to-day, your work or anything, but you will be pulling from trusted source. And the other thing that we also need to investigate in our is some things that we have to do. Locking down CI/CD, like we have to take measures. If you have a project, if you have a GitHub repo, if you're a maintainer, you have to pay attention to your CI/CD. And nowadays, like we all use CI/CD for something, right? For running tests, for whatever. So we have to be more intentional and careful with the actions we run. They can introduce obfuscated risks because you are not actively looking all the time to the logs or to the execution. It's something sometimes like cron jobs that run on schedule on GitHub Actions every day. And if you point to GitHub action that is compromised, then you don't know until the news is out there, basically. And then you have to run and reset all your secrets and vars, everything. So it's very important to pin GitHub actions and also container images to a digest instead of a tag. Like I mentioned before, I repeated this many times already, I think. Don't use PATs, don't use personal access tokens, long-lived tokens. Ban those from your organization. Use short-lived tokens instead. Use malware scanners when appropriate. If you are worried, you can try to set up a GitHub action to run malware scans with the malcontent project that I talked about previously. And rule sets are also important. Other controls that you can to protect branches and tags. This is also important from the maintainer side. And keep things updated. So this is the thing about using a digest. The only downside of using a digest is that your GitHub action, your container, whatever, will go stale because it's not updated. It's always pointing to the same build, so it will not automatically get updated. You need to update the digest. So we have tools for that. We developed a tool called Digest-a-Bot that you can use. It works as Depend-a-Bot, so it's very similar. And there is also a tool called Renovate that you can use to update also not only digest, but dependencies also. It's important to keep the mindset of keeping always things updated. This is really important to patch early and be effective. Because if you wait until it hits the news, then your secrets are gone already. When you go to production, so this is also something that you can implement for as a strategy to mitigate risks on production environments on your Kubernetes cluster. Use policy as code. So you can use OPA Gatekeeper or Kyverno to establish a policy for instance, to restrict registries or sources. Like you can create a policy to say that you only accept images coming from the Chainguard registry, for instance, or blocking specific registries that you don't want to run. The image coming from this registry cannot run here. Use latest tag, not allowed to, shall not pass. So there are things you can do with these policy engines to enforce restraints on the sources, and also require signatures and SBOMs, for instance. is also good, because then with SBOMs, you can have more visibility on the versions and everything that is installed on your cluster. It's important that your images also have SBOMs. Chainguard images have SBOMs. All images have SBOMs. And you can start in audit mode first to see how bad it is, the situation, to see how it would impact. And then later you can enforce. Okay, we are reaching the end. And I want to share some concrete actions for developers, dev actions. You can do these sprints, least amount of friction. You can start right away. To when 2026 starts, you already have a good start for your software supply chain security. So first, it starts with auditing your containerized workloads. Check all your Docker files, check your CI/CD, whatever is containerized. Have a look at that. See what you're using for base image and gripe scan for CVEs. I will show you how to do that. So run gripe to check CVEs, vulnerabilities on your container images. Check image size, the amount of dependencies, because the bigger the image is, typically is because there are more packages installed. Depends, of course, if you copy a huge application inside a container, and then it's going to be bigger. But base images, usually you compare by size, it will tell you the attack surface. Look for insecure defaults. Also, image run as root. This is not good. Outdated builds, not pinned by digest. Look at your GitHub actions. Look at your container, your Docker files, and start pinning by digest today. And then choose one Docker file to try to convert to Chainguard images. So there is a tool called a DFC Docker File Converter. It's an open source tool our engineering team created to facilitate migration. The thing is, Chainguard images are based on APK. So a lot of people are used to Ubuntu images. That are based on apt get, that stuff. Chainguard images are based on APK. So it's a different package manager. So you need usually to convert some commands on your Docker file. Also, of course, change the base image, and sometimes a few commands must be converted. So DFC helps with that. And then run the gripe scan again and compare the results. So this is something that you should do on your own to verify that this is all true, what I'm talking about here. So I have a little demo. Is going to be quick because we are reaching the end. And I wanted to share two things that I wanted to show. So here at the bottom of my screen, I have some examples of DFC, some examples to run DFC. Let's see the basic one. So I have here a Python Docker file. It's a very simple Python Docker file. This is actually already converted. So let's find another example. This is already converted. Python. This one. Yeah, I have a lot of examples here. So Docker file is I think it's multi-stage. Yeah, it's a multi-stage Docker file here. So we build here the app, and then we copy the contents for a runtime that is slim. And now I'm gonna run the DFC Docker file just to show you how it would convert. DFC doesn't change the Docker file. It outputs to std out the converted results. So here is what it would look like. So there is the image change, the base image change, and then we have to add user roots because our images by default run as a non-root user. So if you want to install packages, you need to add a user root directive. And then you come and then you can install your packages, APK, adds. No cache, don't need to apt updates. Here is APK adds, no cache. And then the packages, and then some things, some Python things, install, use pip to install things. And then another stage here based on Python, Chainguard image. And this is because there are some instructions. You need some package here, so it needs to run the dev version. So this was just to show you how the DFC conversion works. And I wanted also to show you a few, I think I have to do this. Yes. So the other thing I wanted to show, we don't have a lot of time left, but it's a development environment that I built for Laravel development. So it has actually, it's a Docker Compose with Nginx, PHP, FPM, and MariaDB. And so these 3 images, if we get like a account for all the CVEs in all these images, it's a lot of CVEs, you know. So I have here you can go to images.chainguard.dev and use the search box here to search for the image that you use, whatever is your stack. In my case, PHP. And then you can see the comparison tab. Then you will see the comparison between Chainguard image and the equivalent image from Docker Hub. So PHP, it used to be worse, but still we have quite a few vulnerabilities here. 10 medium right now. The thing is that vulnerabilities can be chained together. So from one medium in another one, combined, they can access things. But yeah. So these we have like a 20, 16, no, 20, total 16. Okay, 16. And then Nginx here, there are more. So we have 29 here on Nginx. So this is like 45 vulnerabilities already. And then MariaDB. MariaDB used to be very bad. You see this here? More than 1,000 medium vulnerabilities. And you could gripe scan it anytime, it would be terrible. And I even talked to a maintainer at an event at the AWS, I think it was, it was an AWS event in Amsterdam. And occasionally, one maintainer, someone from MariaDB was at our booth, and then I thought there was something wrong with the charts, but actually it was right. It had over 1,000, and he didn't believe me. But I talked him you need to update your base image, because they were using Ubuntu 22, I think, as base image for their official MariaDB images, which is really bad. And I talked to him you need to update, talk to your team. And then maybe that worked, because now just here in December, there's a big change. See? So now only 87, but it's much better than like 1,000s. But our image has 0 CVEs as of today for MariaDB, and as of November, and for a long time, actually. So, and that's all I have for today. We have not much time left. I'm sorry about that, but there was a lot to cover. So if there's still time for some Q.
I feel scared but hopeful.
Yes, the same. I feel the same.
Do you think we should have time for 1 or 2 questions, or?
Yeah, I think we still have like 4 minutes. Let's see, at least one question. Do we have?
We did have a question about the Python version you were using. I'm not sure. There might be a good opportunity. I think maybe you were using 3.9, which is a little bit of an older one, but it might be a good opportunity also to talk about Chainguard end of life or something.
Yes, actually, that is a very old Dockerfile I had to test the conversion of Dockerfile, DFC conversion. So it's not anything that is usable for anything, actually. Sorry about that.
Don't use 3.9.
Don't use that. Yes.
It was a great Python version back in the day, but not today. Great.
Not anymore.
Anything so I don't know, I guess I'll just ask another sort of more general question about like, where do you think the sweet spot is? I know it depends on organization to organization. There's no perfect question to this, but we know not to pin to latest. We know not to use really old versions. Is there a sweet spot?
Well, I think pin to digest is still the way to go. I know it's kind of annoying to have to update often, but it's very risky to use anything that is mutable. If you, of course, development, I still use like tags, or I even use latest sometimes for developing on my machine on containerized environments. But for running GitHub Actions, you really must pin to digest, like not only the GitHub action, but any images that you use in your GitHub Actions,
yeah,
and production also, on production staging, things that go live. Yeah.
All right. Well, thank you, Erika. And I think we're leaving a lot more informed than we came in. And
yes, have a good one. Bye, folks. Thank you.